Hey guys, here is your video to help you find the area under the curve a little bit better. No, I don't know about better. Actually, you guys did a really good job with your findings. In some ways, your way is probably more accurate than what we're going to do for tonight. But for tonight, we just want to have a consistent method for estimating the area under the curve above the x-axis. Okay, and then tomorrow I'll reveal what the correct answer was to this problem and show you how to get it 100% accurate. So the first thing we're going to do is realize that we're just going to stick to rectangles. You guys all had great ideas of how to break it down. Some of you did like triangles. Some of you did, squares and then triangles. Some of you just counted the boxes and made rectangles. Whatever. They were all really good strategies. But for right now, we're going to do rectangles, and I'm always going to start from the left to make my rectangle. Okay? So we're going to call this the left-hand rectangular approximation method. And we're going to do 5 rectangles. Okay? So the left endpoint rectangular approximation method. And we're going to do 5 rectangles. So if I'm going to go from 0 to 5, right, because that's what we wanted to do, I'm going to start with 0 and go directly from left to right to get to my next breaking point. So obviously, if I'm doing 5 rectangles from 0 to 5, I'm going to break at 1, 2, 3, 4, right? Or, 0, 1, 2, 3, and 4. So from 0 to 1. Now, there's no height for this one at 0, right? So this first one really isn't a rectangle, but just follow my lead here. It'll make more sense in a second. So start at your first endpoint, go up to the curve. In this case, it just happens to be 0. Then go over to your next endpoint, and then there's your first rectangle. Here's one that you'll actually get to see better. So our next breaking point is 1. Go up to the curve, come over to 2, and then down to your next breaking point. All right, sorry for that interruption. I had some rude visitors that just would not leave me alone. So now I will continue. Karen and Caroline, excuse me. So, all right, so our second rectangle went from 1 up to the curve, over to our next breaking point, and then back down. So this is our second rectangle technically. All right, now we start at 2. Go up to the curve, over to where the next x value would be, and then back down. Up to the curve, over, and down, and then up to the curve, over, and is that it right there? Yeah, right there. And down. So here are our 5 rectangles. Now clearly this is like an under approximation, right? I mean, there's all this other area not accounted for. But this is basically how you do it, and we're just starting here, just a little one step at a time. So our area will be base times height, of course. So our base is 1, our height is 0. So base times height plus base times height. Now in this case, our height is 1 squared, which is 1, plus base times height. 2 squared, right? That's 4. Right? Everything's coming from here, right? Our equation is telling us our y values, which is our height. Then our base is 1 and our height is 9. And then our last base is 1 with our height being 16. For a grand total of 16, 25, 30. So our first approximation is 30. This is our left-hand approximation with 5 rectangles, and it is clearly an underestimate of the actual area. All right. I would hope that you realize that if we did more rectangles, we'd probably be able to get this a little more accurate, but you're probably not going to need to do quite so many, maybe 6, 8, something like that. And we'll explore more rectangles later on, but just get the basics. So you're using rectangles to find the area under the curve. You're going to use a left-hand approximation method sometimes, and sometimes you're going to use a right-hand rectangular approximation method. So I'm going to do that with 5 rectangles. I'm going to use the same picture. I'll do it in blue so it should stand out a little bit more. And the only difference between doing a left endpoint method and a right endpoint method is instead of starting literally at the left point, you're going to start at what would be the next one and go up and then back, right? So you go up to the curve and then back to the next, to the previous point. I can't really do that at 0 because there's nothing to the left, but I can start at 1, go up to the curve, and come back. I'm basically making a rectangle using the right endpoint as my, the value I use to get my height. So this is my first right-hand rectangle. This one actually does have value. My next one would go up here, and this time come back and down, up back, and down, up, back, and down. I mean, I'm really starting down here. It's just already drawn, so it's hard to see. And then again, up, back, and down. And quickly you can see in this case that my right-hand approximation method has my rectangles, you know, above the curve, right? That's above the curve. Okay? So this is going to be an over approximation. This is going to happen if your function's increasing, your right hand will always be above and your left hand will always be down. If it was decreasing, it would just be the reverse. All right, let's find our area, and we'll see that we're going to go too high this time. So this time it's basically, if you think about it, it's really the same rectangles we had before, but it's all just shifted. Right? Our first one is 1 times 1 squared. And then it's 1 times 2 squared. Right? Look, it's right here. And then it's going to be 1 times 3 squared. And the only one that's really, 3 squared, so that's 9. And then the only one that's different is now we're including this last one here that we didn't have before, that came from using 5 now as the indicator for height. Right? So 5 squared is 25. We didn't have that before because it only went up to 4. Right? It was 4 squared, and that gave us our last rectangle. So this is going to be plus 1 times 25. So my actual area is going to be the same area as before, except I have 25 more than I did in the first place. So that's going to be 55. All right, that's clearly way above, right? So we have one way below, one way above. So logically, I would hope you'd say, all right, what if we just took the average of those two? And that's not a bad idea. But that's not actually one of the methods we're going to use. But you certainly could. If I asked you to give me an approximation, like your best approximation, doing the average of those two wouldn't be a bad idea, but you're not going to need to, so don't waste your time. Because we have another method called the midpoint rectangular approximation method. And that's going to basically take care of the average-ish. It's not going to be the same thing. It'll be a little different, but it'll be a good approximation, so we'll start with that. And the only difference is for that is you start in the middle. So don't start at 0, don't start at 1, right? If you know you're doing 5 rectangles and each base is 1, start at a half. Go up to the curve, come over, and down. And these I'll actually color in so you can see them better. There's our first one. So my base is 1. My height is 1/2 squared. Here, I'll actually write it out the whole way so you can really see where that's coming from. 1/2 squared plus, now this time I'm going to go to 1.5. I'm going to go up to the curve, come over, down, and over, and down. And this is my next rectangle. So there's a little bit above and a little bit below. And they don't quite cancel out perfectly. If they did, this would be great. But unfortunately, it's not perfect. But at least it does account for it, right? In the first example, the left hand was too low, and the right hand was too high, and there was no accountability for it. The midpoint actually accounts for a little above and a little below, so that helps. So this is going to be 1 times, that's 1.5, so that's 3/2 squared, plus 1 times, this is going to be 5/2 squared, right? So up, over, and down. And there's the next rectangle, using the midpoint. That's 5/2 squared. Times plus 1 times, this is going to be what? Let's go up here, over. Right? So that's, oh good lord, 7/2. 7/2 squared. And then last one, 1 times, it's going to be what? 9/2. Let's go all the way up. Over and back, over and down. There's our last rectangle, using the midpoint. Right. By the way, you obviously can rewind and replay if you want to watch left, right, or mid individually. And that's going to be 9/2 squared. So let's put that all together. That's going to be 1/4 plus 9/4 plus 25/4 plus 49/4. It's nice when the base is always 1, right? Plus 81/4. So that's 81, 120, 130, 155, 165/4, which is 41.25. I don't remember what our average was on our document. If we take out like the highest and lowest, I think it's probably pretty close to that. I think we were in like the 43s maybe. And I know we had a couple of outliers, but it's still in the low 40s. That's pretty good. That's not exact, and I'll show you tomorrow what it is exact, but that's not bad. All right, so this is the rectangular approximation method, and this is all you really need to do for those 2 problems from the homework. I think it was page 325, number 2 and 5, something like that. So you got your left-hand rectangles, your right-hand rectangles, and your midpoint rectangles. And there's all 3. All right, guys, good luck. Let me know if you have any questions, and I will talk to you soon. Peace.